Covalent compounds are made when two nonmetal atoms come together to share their outermost electrons, their valence electrons. When a pair of electrons is shared between two nonmetal nuclei, this is called a covalent bond. So two electrons shared equals a covalent bond. Nonmetal atoms will tend to make the number of bonds that are equal to the number of empty valence spots in their valence shell. Remember that the valence shell can hold 8 electrons. So since carbon has 4 electrons in its valence shell, it has 4 empty spots and can make 4 bonds. Nitrogen can make 3 bonds because it has 3 empty spots in its valence shell. Oxygen can make 2 bonds because it has 2 empty spots in its valence shell. And finally, fluorine can make 1 bond because it has 1 empty spot in its valence shell. Since atoms within the same column or group have similar properties, anything in group 14 will tend to make 4 bonds, group 15, 3 bonds, group 16, 2 bonds, and group 17, 1 bond. In addition, hydrogen has 1 empty spot in its valence shell, and so it will always make 1 bond. So for instance, if we make a compound between carbon and hydrogen, we will need 4 hydrogens for every carbon because carbon needs to make 4 bonds and hydrogen makes 1. So each hydrogen can make 1 bond to the carbon, giving carbon 4 bonds. If we represent the carbon by a black ball and the hydrogens by white balls, then this compound would look something like this, where we have 1 carbon and 1, 2, 3, 4 hydrogens. If we want to make a compound between nitrogen and hydrogen, we would only need 3 hydrogens to every 1 nitrogen because nitrogen should make 3 bonds. If we represent the nitrogen by a blue ball and again the hydrogen by white balls, that compound would look something like this, with 1 nitrogen and 1, 2, 3 hydrogens. If we want to make a compound between oxygen and hydrogen, then we would expect to need only 2 hydrogens for every 1 oxygen to give the oxygen 2 bonds. This compound would look something like this, and you'll probably recognize that this is water. Finally, if we want to make a compound between fluorine and hydrogen, then we would expect to only need 1 hydrogen for every fluorine. This compound would look something like this, with the fluorine represented as the yellow ball, and again the hydrogen as the white ball. When we symbolize these compounds, unlike for ionic compounds, we're going to actually use the total number of each type of atom in the compound. So this compound between carbon and hydrogen, which contains 1 carbon and 4 hydrogens, will be symbolized as CH with a subscript 4 to indicate that there are 4 hydrogens and 1 carbon in this compound. Likewise, we would symbolize the compound between nitrogen and hydrogen as NH3 and water as H2O, and finally the compound between hydrogen and fluorine, hydrofluoric acid, as HF. Unlike ionic compounds, which form infinite lattices of ions, covalent compounds form discrete units, like this carbon and hydrogen molecule, CH4, or this carbon-hydrogen molecule, which contains 2 carbons and 4 hydrogens, or this carbon-hydrogen molecule, which contains 4 carbons and 8 hydrogens. Therefore, it's important that we symbolize these using the total number of atoms in the molecule, in the compound, because this compound here would be symbolized as C2H4, and this compound would be symbolized as C4H8. Notice that the lowest whole number ratio for this compound is CH2, and the lowest whole number ratio for this compound is also CH2, because both 4 and 8 are divisible by 4, so I can reduce this to CH2. Both 2 and 4 are divisible by 2, so I can reduce this to CH2. So the lowest whole number ratio for these two compounds is exactly the same. However, they are very, very different compounds and have very different properties. Thus, to distinguish all covalent compounds from one another, we must use the total number of each type of atom in the compound to symbolize that compound.